Hello everybody, welcome to Infinite Maths. In this video I'm going to share about trigonometric ratios for 60 degree, 45 degree. I hope you enjoy this video. Let us take one right angle triangle whose base angle is 60 degree. And this is A, this is B, this is C. And this is 90 degree. Angle sum property of the triangle will make it possible that this angle happens to be 30 degree. Now, if I draw a line from here such that this happens to be 60 degree as well, then these 3 points will form such a triangle whose base angles are 60, 60. That means the vertical angle must have been 60 degree as well, because it had to be like one, which makes these 3 happens to be supplementary. Now, these 3 happens to be equilateral triangle, hence if this is of x measurement, this is of x measurement, then this would be of x measurement as well. Since this angle was 90 degree and I have already taken out 60 degree from there, that means I am left with 30 degree. This is 30, this is 30. If you carefully see the triangle formed by DAB, it will be an isosceles triangle, as base angles happens to be have the same measurement. And eventually, since equal angles have got equal sides opposite to it, so BD will be having the same number as AD would contain. That means if BD is containing x, that means AD is containing x as well. So, circumstances have taken us to conclude that this length is of 2x and this length is of x measurement. Right? What about this length? See, this is AB, and since Pythagoras can be applied over here, AB square plus x square happens to be 2x square. That is, AB square plus x square would eventually give us 4x square, and AB square is good enough to be 3x square. Right? And if we see AB only, then it must have been root 3x square. And eventually we will reach the conclusion that AB would be of measure root 3x. So if I am talking about sine 60, that means I am talking about P upon H. That means I am talking about perpendicular upon hypotenuse, that is root 3x upon 2x. That enables us to give us root 3 by 2 without any variable. Similarly, if I need to have cos 60 for my measurement, that means I am going to see the ratio between B and H. Then B is of x units and AC is of 2x units. That means x upon 2x is of good use. And eventually I can land up with tan 60 as well, which is of P upon B. That is, P is of root 3x, whereas B is of x only. That means I can have root 3 as its measurement. Please copy it down so that I can tell you about 45 degree as well. I hope I am clear with my point. So pause this video and copy it out. See, if you are concerned about 45 degree, then let me tell you, being this as 90 degree, this as 45 degree, this angle will be of measurement 45 degree. And at the end you can see that this is an isosceles right angle triangle, and this much length is good enough to be equal to this length, as equal angles have got equal sides opposite to it. If this is of x measurement, this must be of x measurement as well. And Pythagoras will reveal that x square plus x square is good enough to be BC square. That is, 2x square is good enough to be BC square, and eventually root of 2x square is equal to BC, and we can in easier terms write this as what BC. Right? And if I see sine 45 for that matter, then I see P upon H, then I see x upon root 2x, and I am getting 1 upon root 2 as its ratio. And if I am concerned about 45 cos 45, then I am concerned about base upon hypotenuse. Base is of x measurement again, and hypotenuse of root 2x measurement, and eventually I am landing up with the same number as I have landed up with sine 45. And tan 45 and x base perpendicular upon base, and since they both have got same measurement, so we always get 1. I hope I am clear with my point so far. You should not be learning all these things, you should be understanding all these things, right? I hope you have enjoyed this video. Please keep watching Infinite Maths and keep supporting us so that we can bring you more interesting videos about mathematics. Thank you and so much.